What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we are going to do Codeforces round 660. So this was I did terrible in this contest, not gonna lie. I couldn't even solve the first problem, so that was awful. That was absolutely terrible. But yeah, I was able to after looking at the editorial, it was actually a very basic problem. I might actually explain that in another video. For now, let's just do upsolve these next two problems. All right, so let's look at this. All right, so I'm gonna try to solve these two problems next, and then see what we could do. All right. Okay, Captain Flint in Long Voyage. Okay. So in the beginning, he wrote on a board a value of x consisting of n digits. After that, he wipes out x and wrote k instead, which was the concatenation of binary representation of digits x consisting of without leading zeros. So if x is 729, k becomes this. Since 7 is 111, 2 is 10, 9 is 1001. After some time, I understood that he doesn't know what to do with k and asked Dennis for help. So Dennis will decide to wipe last n digits of k, rename the new number r. As a result, he proposed to find this integer x of length r that is maximum possible. There are maximum x is an integer to find the minimum one. What does that even mean? Hold up. Okay, yeah. What does that even mean? Let me do a pop-up real quick. Oh my gosh. What does that even mean? Okay, let's see. Let's try to break this problem down. First of all, I gotta close the door for a real second. Sorry guys, real quick. Okay. All right, so let's try to break this problem down and try to figure out what we are doing. Okay, in the beginning, you wrote a board a number x consisting of n digits. You wipe x out, you wrote k instead, which has concatenation of digits x. So k is a concatenation of digits x. Okay, so here k has 11 because so x has digits 729, and 729 represents these in binary, and k's binary represents these in binary. I think that's what they mean. Yeah, that's what they mean. Let's see, 11, 111, 10, 111, 10, 1001. Okay, so k is just the binary representation of x using the digits. Okay. After some time, he understood that he doesn't know what to do with k. So now he decides to wipe the last n digits of k. So wipe the last n digits of k. Okay, so you get rid of the last n digits and name this new number r. As a result, he proposed to find such integer x of length n that r is maximum as possible. If there are multiple valid x, then you need to find the minimum one. Okay, let's try doing this basic code. Let's try just reading in t, and then we'll read in n, the single integer n, and the length of the integer x. So yeah, so next n consists one and only line of each test case consists of integer n. Okay, so each test case consists of integer n. Okay. Oh yeah, so this was the code for the beginning. I might do an explanation of this later. But yeah, for now, okay. Now we have to, okay, so we have a value n. So okay, so each value, we need to print the minimum integer x of length n that r is maximum possible. Okay, so yeah, so we input 1, it's 8. If I input n is 3, Uncle Bona has x equals 998. Then k is equal to that. You could wipe the last 3 digits and you will get r is equal to this. This is the largest possible r can attain, and N9998 is a minimum x to obtain it. Minimum x to obtain it. This is very tricky. This sounds like bitwise. I'm not sure though. Let's see. How you guys doing? Anyone in the chat? Okay. What math is important in competitive programming? Basic algebra, forming equations. That's very, very, very important. Number theory, like basic stuff like prime factorization, remainder, like stuff like that. Finding a remainder, number theory. That's the important part. Other than that, there's some computation geometry questions, but I don't think that's that important. Like in the beginning, the best thing, the important math that you need is just number theory. So like stuff like find the remainder, stuff like that. Like modulus, like arithmetic, which is like, yeah, that's just number theory. And you might need probability. Probability is important. And then another one's combinatorics, which is like permutations and combinations. So that's important. So those are the three things you really need. Basic algebra to form equations. Second is like number theory, do stuff like that. Combinatorics, finding like permutations, combinations, probability, and then probability. That's the most math you would need. Anyway, let's get down to this again. All right. Let's see. Back to this. Okay. Second case n is equal 3. Okay. I'm trying to. My brain is not working right now. Okay. So we need to find. Okay. So we have a number. Okay. So we have a number n, which is a number of digits, right? In the beginning, Uncle Ben wrote on the board a positive integer x that contains n digits. You wipe out x and you write another number k. K is converting each number to binary. After that, you decide to wipe out the last n digits of k and rename that number as r. Then now what you want to do is you want to find an integer x of length n that r is maximum possible. You need to find an integer x of length n whose r value is the maximum as possible. Okay, I'm actually going to write this down as I'm going to write this down in comments. So what did they do? They took number x has n digits. Okay. Then what do? You wipe x out. You wrote k. So now you have k. So now you have k is each x digit converted to binary, which is like 1001s. Then you need to find integer x of length n. Find integer x that r is maximum possible. So find integer x whose r is maximum. Wait, okay. Remove, oh yeah, I forgot. So k is each digit in x converted to binary. So hold up. Each integer x converted to binary. So k is each integer x. R is going to wipe out the last n digits. So r wipes is wiping out last n digits of k. Okay. Okay. So I think that's the whole question. Okay. Now find the integer x whose r is the maximum possible value. Okay, so that's I think I made the gist of the problem like this. So number x has n digits. K is each integer x converted to binary. and added it to each other, right? Concatenated. Okay. R is you wipe out the last n digits of k. And now we need to find the integer x, whose r is the maximum possible value. Okay. Okay. So let's see, what is the maximum? Okay, let's go basic. So what is the maximum possible value a number can have that has n digits? So if I have n is equal to 2, I think the maximum possible value is for each digit put 9. Right? You would have, so if the maximum possible digit of n digits of 2, number x would be 99. Yeah, right, because each digit is 99. That would be the max, I think. Now you're going to convert k of so here's the thing, is like if you wipe out the last n digits of k, I'm not so sure how that, okay, so like let's say I have, so let's say you have n is equal to 2, and this is my guess. I'm guessing the maximum number you could possibly have is 99, right? Because for each digit you have the max number is 9, right? And we have n digits. So like let's say this means x is equal to 99, right? K is going to be x converted to binary concatenated. So let's convert n to let's convert 9 to binary. 1001. So that would be 1001. So that would be, k would then equal to 1001 and concatenated with 1001. Right? You guys following along with me? Now we're going to wipe out the last n digits of k. So that would be the last 2 digits of k. So that would be, these are going to become gone. So that's going to get you to, r is going to equal to this, same thing, but we're going to get the last 2 digits. So that this, find the integer x whose r is this r the maximum possible value? Let's see. If I convert this r back to, do they convert the r back by digits? Let's see. Okay, so it's not just 999. Okay, so let's see. 1008. Huh. Is the minimum x to obtain it with. R would become 100. Okay, 10001100. And this r is the maximum possible r. Is this still in binary, or is it see, there are multiple x, then you're interested to find the minimum one. Multiple x, you can find the minimum one. Okay, so we need to find the minimum x whose r is maximum possible. Whoops. Okay, so find minimum x whose r is the maximum possible value. Okay, so if n is equal to 2, this is my guess, but this r isn't the maximum, or is it? Let's try it. Let's say n is equal to 2, and let's do another case. Instead of x is equal to 99, let's try x is equal to 98. Let's see what would happen. So 98 would be converted to binary, would be, what's 9 in binary? Let's see, 9 in binary would be, well, yeah, 1001. And then 8 would be 1000, I think. 8 to binary. Let's see, 8 to binary would be, well, yeah, 1000. So then that would be this thing concatenated again, which 100, right? And then let's remove the last, r is going to equal to, let's remove the last n digits. So remember, n is still 2, so let's remove these 2. And then you have this. Whoops. Right. Is that greater than this R? That's actually less. That's actually less. So X is actually less than. So this X98 is actually less than the value of X is 99. And the R is actually the same. Huh. That's strange. Okay. So the R is actually the same value. So if you were to pick for this scenario n equal to 2, it should be 98. Let's try again. Let's try another one. So if let's say X is equal to 97. So let's keep going down and see what happens. N would be 1, 0, 0, 1, and then I mean K would be that, and then 97. What is that? What's 97 to binary? What's 7 to binary? 7 to binary. 1, 1, 1, 1. Okay, so that'd be 0, 1, 1, 1, 1. So then that would be 0, 1, 1, 1, 1. That would be this. R would be get rid of the last 2 digits. So let's do this here and then get rid of the last 2 digits. R would be this. And I think this is not as great, isn't as maximum as the other one. Okay. Okay, so I think it might have to do with 98. I think it would be always be 98. I'm not so sure though. Let's see. Let's go back. Yeah, I'm guessing that you just concatenate 99 with all the values and just put an 8 at the end. I'm not so sure though. Based on how we're going through here. So I'm gonna try that, and if that doesn't work, then I don't know. I don't know. So here we're gonna do up to n-1. We're gonna do print out 9s, right? And then here the last one we're gonna print out an 8. I don't know if this actually will work because I don't know. So it's like based on how the input is, that could just be it, right? So then you have 8 and then 9998. So let's see if this works. I could be completely wrong. I'm not gonna lie. If this is the answer, then I really should have attempted this problem first. Okay, we got wrong answer on 2. Okay, so that means that's not the answer. But we did pass the first test case, so that's good. Okay, yeah, so it's definitely not the answer. Because the output, let's see. Words differ. Expected 99999888888, but we found 99988. Ah, so based on the output, we actually repeat 8s. So we actually should repeat 8s. Let's see. Okay, so I know it has to do with 8. So I think I'm not wrong on that. What do you guys think? Okay, for big companies, they normally usually code questions. For startups, it depends on your project and your behavior questions. So if you're trying to get into like a big company like Amazon, they kind of ask questions similar. Well, it's easy. The questions are easier than these. Okay, not gonna lie, they're easier than these, but yeah, it's leak code pretty much for like Amazon, Google, Facebook, stuff like that. For smaller companies, they don't really ask you these questions. You have to, for like startups, stuff like that, you have to like, it's all based on behavior. You know what I mean? So yeah, it does, finding an internship, it actually just depends on what company you're interviewing at, really. That's what but yeah, I have interned before. Yeah, I've interned at a defense contracting company, which is like a defense stuff like that. But they ask me mostly behavior questions. I've also gotten offers at some I've gotten some offers at some other tech companies. They're not like the main like big four, but I did get asked some lead code questions. I'm not gonna say where I entered at, but yeah. Anyway, back to this problem. So let's see. Maybe we should brute force. Okay, so like currently all I did was just print out 8 for the minimum. But what if we were to start at 99 and just keep going down, then converting every value into its equivalent binary, then get rid of the last 3 digits and then set that as a new value and then keep doing that. See, yeah, I think that would work actually. We might get TLE though. I don't know if they want us to do this in like one line or not. Hold up. Okay, so let's try going down. So first let's create a string. All 9s. Actually, see, we need to. Okay, let's call our number. Let's call it a number, and we need to create 9999s with the size of n. So let's start with it as 0, 1, and then we're gonna loop from I equals 0, I is less than n, I plus plus, and then what we're gonna do is we're just going to multiply number times 10, right? We're going to multiply number by times 10, and then we're going to add by 9. Yeah, so we're going to here times 10. Oh, no. Yeah, we start here. Let's start at 1. So we're going to start 9. So then now we're going to multiply by 10 and then add by 9. So here, let's number multiplies equal to 10. And then we're going to number plus 9. Because then if we do that, if we multiply by 10 and add 9, that will concatenate that number of digits. Let's just see what that does, just to make sure we have sanity. Sanity check. So what we're going to do after that, we're going to loop through downward, right? So then we're going to loop down from 9999, and then we're going to convert each number to its equivalent binary, and then we get the x and r, x, k, and r, and then we try to find the one with the maximum r in the smallest x. So yeah, that's what we'll do. Yeah, I think that should be an O of n solution. I don't know if they want us to make it faster or not. But anyway, let's see. 3 should give, okay, so 3 should give us 9. Okay, so we're gonna do n minus 1. Yeah, so that would give us, let's see. Okay, so with number 3, we got 999, so that's right. So if I do 3, it's gonna give us all numbers that have a digit 9. That's what it'll do. So now I'm going to loop from yeah, I'm gonna loop from this actually, yeah, so this actually does take quite a while actually, now that I think about it. Let's loop from number and then down to 0. All right, let's do that. And then what we're gonna do is we're gonna convert each digit of number to its binary. So yeah, let's do that, and then so let's try that. So remember, maximum digits is 9, so I might actually just create an array. So like create an array of digits, of string of digits. So let's do digits, and then I'm just gonna brute force writing the digits of strings, so like of all the binary values that have strings. So let's do like 0 to 9 in binary, right? Because it can only go up to 0 to 9. So like if we just brute force the strings, we could just do that. Let's do that. So the first one's 0, the next one is 1. Third one is I'll just copy all of these actually. Up to these, yeah. So let's do that here. Okay, next one. 100. 101, 110. So we don't need that. 111, and then 1000, and then 1001. Okay. So this is just the brute force implementation. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah. So yeah, so these are all the numbers in binary. So like 0 represents 0, 1 represents 1, 2, 3, wait, 0, 1, 2, 0, wait, hold on, I think I missed one. Did I miss one? I think I missed one. 2 is 1, 0. Yeah, 2 is 1, 0. What am I doing? Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that represents that. So now what we're going to do is we're going to convert each digit of x into its equivalent digit. So I'm actually going to loop from x down to wow, this is actually 2 for loops actually. So that might actually get TLE. Let's just continue doing it just for now. I'm going to loop from 0, y is less than number of digits n, y plus plus. Okay, so for each digit we're going to add concatenate. We're going to concatenate the values. So I'm actually going to do this outside for now. So then just to make sure I'm right. So let's see. Let's create a string, empty string, current number. Let's call it k. And then we're going to do k plus equal to, let's see, number at, okay, so we should actually make this into a string. So, because if I make the number, wait. Yeah, okay, let's make this into a wait, hold up. Yeah, let's make it into a string. Let's make this into a string. Let's make the number a string. So now now this just concatenates 9s. So okay, here then what we're going to do here is that we are going to loop through from, oh yeah, right here. We're going to just convert every single number into its equivalent number for, yeah. So number at y, which is a character. So I'm going to go through every digit of number. So number is the one we had 9999, right? I'm going to go through every digit, convert into binary. So let's do that. So number at y and then the corresponding digit. So it'll be digits. We should actually convert this back into its equivalent. So this is a character. Let's convert it into its equivalent number. I think it's like -97, I think. Let's see. Convert number from string to integer C++. I think it's -97, I think. I'm pretty sure it's -97. I don't want to use IO stream. I don't want to do that. There's definitely a way. So the casting is not a good idea. Oh, -0. I think, yeah, -0. Okay, so that'll convert it into its equivalent number. So if it's 9, it will give me that. And then now I just have to add it to k. Sorry guys, I'm not sure if you guys know what I'm doing here. But I'm just converting it, I'm just appending the value, converting the number into binary. So for this one, I'm just starting out with 9999 and I convert it into its equivalent binary. That's what I'm doing here. And then I'm going to do the same thing down here. So then after that, we could just do a for loop going downward from 9999 and then down to 0, and then we could just find the maximum R value after you wipe out the last 2 digits, right? So yeah, that's what I'm planning on doing. It's a lot of conversion, but I think it's probably most brute force way you could do this. So yeah. So now, yeah. So let's see what we get if I do 1 3. Okay, so we get this. Is that the same? 1 0 0 0 1 0 0 1 1 0 0 1 1 0 0 1. Yeah, that's right. Okay, that's right. Okay, so that's actually right. Okay. Let's see. Let's see if we have. Let's say number was not 9999 but 9998. Let's just see if what that does. So let's comment this out. Let's see if number is 9998. Let's see if that would change anything. So 1 3. Okay, so that does change everything. Okay, so let's see 7. Okay, so that's good. Yeah, 1 0 0 1 1 1 1 1. Yeah, okay, so that's right. Okay, so now we have that. Let's make number back to its original. So now we have that. Now let's just brute force this. So now we have k. So now let's take this k and put this into this for loop. This one. Wait, not this one. Not this one. Not this one. This for loop. So now I'm going to loop from 999 down to 0, and then I'm just going to get its binary and find the maximum one. So yeah, this is definitely brute force. So now number is a string, so let's convert this to a number. So let's see, convert string into number. C++. stoy. You could use stoy. Yeah. So let's do stoy. stoy number. Is there a long? stol. Stol. String toll? Does it convert to long int? We might have like issues with that. Stol. Oh yeah, okay, long string toll. This one. Wait. String toll. Oh, whatever. Let's use this one. It's gonna convert the number into. Wait, hold up. Yeah, let's just use this. Yeah. Base 10. The current string. Okay, so let's do that. Number. So this is string. PN. What's PN? Wait, what's point it to the. Hold up. What? Optional. I don't know. Let's see. Can I do that? I can't do that. String toll. I thought it converts to number. String end pointer. End pointer. Where's the end pointer? Reference to an object of type char. Value set by the function in the next pointer after the numeric value. Wait, so what did they do here? Did they just create any random end pointer? Okay, well, let's just do that, I guess. And just so it shuts up. And then base 10, I think. I still can't do it. Why? You could definitely convert string to const char, though. Star pointer. There's definitely a way to do this. Hold up. Oh, C string. Convert string to C string. Wait, convert string to C string. I think you could it's just underscore. .c underscore str, yeah. So I could just do this. Yeah, okay, that shuts it up. All right, then we're going to go down, convert each number into its equivalent binary. Number at y. Number at y. What am I doing here? Number at y. Yeah. Not number at y. No, wait, this shouldn't be number y. This should be x at y. X at y. Yeah. Why can't I do this? But x is a string. Oh, x is a number now. Phooey. Okay, so we're trying to convert the number back to a string and convert it down to its equivalent. 0 to x. Let's see, x. Okay, let's do current string is equal to x. To string x. I think I could do that. Does it convert it? Yeah, to string x. Current string of y. Yeah. Yeah. Okay. And then now we have k. Let's convert k back to a integer. So let's do. So now we need to wipe out the last n digits of k. So let's do r is equal to k dot substring 0 to wipe out the last n digits of k. So that's substring. So if I want to wipe out the last 4 digits of k, I will substring from 0 to n minus k, I think. Wait, no. Substring from current string dot size minus n, I think. Why can't this work? What do you mean? Oh, okay. And I need to convert this into its equivalent long. So I have to do this. I have to do an stoy on this. Okay. So this is gonna be string r. Right. R string. Let's call it r string. Now we're gonna convert r string into its equivalent number. So let's convert this into its this. Let's call this an r string. So now r is gonna equal to this. S r string dot c string, and let's pass an end pointer just for shut up. Okay, now we have r. Now we could use a max function on this, because then that'll get us our max value. So let's do a max r value. Let's call it -1 for now, and then we're just gonna call it maximum. Is going to equal to max r value. Okay. Okay, now we have that out of the way. This could probably just crash immediately. All right, so this should I find the minimum x, because we're decreasing x this many number of times, like every time by 1. Then we convert it to binary to find a k, and then ideally we're wiping out the last n digits of k. This might not work actually. Let's test this. So if I want to wipe out the last n digits of k, let's create any string. Now let's create any string. Let's do it up here. Let's create any string x equal to a b c d e f, and let's do cout x dot substring. What's the size? 1 2 3 4 5 6. 1 2 3 6. Let's do substring from 0 to 6 minus 2. Okay. Because we're getting the length of the string, which is 6, and we want to get rid of the last 2. Right, so then I'm going to substring from 0 to 4. 0, 1, 2, 3, 4. Yeah. 0, 1, 2, 3, 4. So it should give me A, B, C, D, with the last 2 wrong. Gone. So I think this would work. Yeah, it would give me A, B, C, D. So yeah, our substring does work. Okay, that's just to test that out. Let's go back to here. This should work ideally. It might crash. I might get like a seg fault, but I'm not sure. Let's test this out actually. Yeah, let's just test this out. Okay, so what was the... Let's test this out with the first test case. Okay. Okay, so we did get an exception. Violation reading location. I've never had this error before. Why is this a violation? Something is wrong. String minus y. Okay, let's see what our string is. Okay, so this should give us, curse string should give us 9 to 99. Oh, it just gives us 9. Okay, that's bad. X should have given us 9999. That's what X should have given us. Oh no. Okay, so n is 8. No, n should give us regular 9. Yeah, that's what it should give us. Yeah, because we only have one digit of 1, so our value should be 9. So that is right. Let's see, what is the problem here then? Okay. So yeah, 1001. Yeah, that should be right. Now you should substring from, this should give us, what is SR string? Why is it 0? String dot size, current string dot size is the length of the current string. Oh, it should be k dot size. What am I doing? Let's try it again. Okay, so just go to 1001, and then it should remove the last digit. So 11100. Change it to that number. Yep, that should be right. Do this again. This time it's going to be 8. Convert it. Yeah, that should be right. Yeah, so max R is still 100. I think our X should, yeah, our X is decreasing. So what are they trying to print? Oh, we're trying to print the minimum X. Okay, so it should print out X later on. So let's do that later. Yeah. Okay, so what we're going to do is now we're going to print out the minimum X. So to do that, since X is going down, let's create a variable min X. Let's call this max underscore long. All right, now what we're going to do is if our current R value is greater than the max R value, then we're going to set this equal to that. And we're also going to set the minimum X value is equal to current X. Current X, yeah. So yeah, that's what we're going to do. And then at the end of this, we should just print out X. So I know that this is actually very inefficient because we did so many conversions and we're also using like 2 for loops. I don't know how they want us to do this, but I do hope that it's right. So let's see, where did they go? Okay, we have another unhandled exception. Length error at memory. Okay, let's see. Our n is 3. Why is our n 3? Oh, wait. 0, 1, 2, 3. What's our y? Y is 2. 99. 0, 1, 2, 0, convert 0. Hold up, that doesn't make any sense. If it's 3, I don't know. Let me read the chat. Torch 1, yeah. My ranking is pretty bad. Not gonna lie, my ranking is pretty bad. This contest I did pretty bad, pretty awful. So yeah, I actually haven't been competing at all for the past time. So yeah, my rank is pretty bad. But yeah, let's see. So like, cause I'm only able to solve like maximum. I'm only able to solve 2 problems. I was able to solve 3 problems before, but it took time. So I'm like wavering. I was green, and then I wavered, dropped down to like gray. So yeah, my rankings isn't that good. Like I'm not like a fast coder, but with enough practice, it could be anything, guys. You could be anything. Okay, let's go back to this. What is our problem? I think when n is 3, we had an issue there. So let's wait, hold up. Did x actually change? 1 should give us 8. Shouldn't give us 9. Why did it give us 8? Oh, wait, I have to do minimum. Whoops. Minimum x, min x. I have to do that. Whoops. Okay. Greater than or equal to. So it should give us 8 now. Yeah, it gives us 8. Okay, so 1 gives us 8. Now let's look at this. Let's look at this weird error exception. Let's debug our code again. Okay, so yeah, 1, let's just quickly just get past this. It might be a simple observation you could do, but I don't know. I'm just brute forcing for now. Okay, so let's see. N is 3. Add 3 nines. Okay. Convert into a string. Yeah. Let's see. You know, I just have a brilliant idea. What if we just print halfway? Just like halfway all 9s, the rest are all 8s. That might. What if that's just the answer? I don't know. That might actually be the answer. I don't know. But yeah, this is actually a good exercise for brute forcing. Not gonna lie. Okay. So yeah, this is the answer. Okay. So 9 and 9 gives us that. Let's see. Let's see 9 and 8. So why is the problem wrong? K 0 to 3. Convert 0 at current string at y. Y is 0. So yeah, it should give us K1001 9. Yeah, it's 9 first. 9 again. Then it should give us 8 for the other one, because y is 2. So current string at 8 should give us, yeah, that's right. Okay. Substring. Okay, that's right. I don't know why I had the error the other time. 9997. So where does it give me an error? 9996. Oh, it might give me an error because when you get down to 0. Get down to 1 or 0. Because then n is not 3 anymore. There's no... Yeah, you have to do... Oh, okay. It shouldn't be... It should be current string dot size. Yeah, okay. Let's see now. Let's see what this gives us. Okay, yeah, so it gives us 998. Okay, so that's good. Let's print this out. So this is a pure brute force way, and it's very ugly code. So I wouldn't be surprised if I like got it wrong. Come on, give me something. Oh, I got past the first one. Let's see the second one. TLE. I'll just sit there. TLE. Oh, damn it! I knew it. It was TLE. Ah, okay. I don't know how else to make this faster. Let's see. Like I know you have to print out. It's something to do with 9s and 8s. But what if I just print out halfway 9s and then the rest 8s? Let's see if that works. Let's try that later. Actually, let's try that right now. Okay. I'm right now not sure if because like brute forcing. I'm not. Once brute force doesn't work, all out of options at this point. Okay. Let's go through n over 2. Print out 9s. And then go from n over 2 plus 1 down to n. And then print out, actually, yeah, wait, actually it would be n over 2, yeah, and then print out 8s. Let's try that. Because you never know what these problems are like. The first two problems they could just be tricky. They could just want to trick you. So like, let's see, this one. 8, 2, oh, well that would 2, 9, 8, 8. Is 9, 8, 8 an answer? Hold up. What if I do this? Wait. Is that an answer? Alright, I don't feel like checking it, so let's just submit it. It's probably not. Okay, yeah, so it's not an answer. Okay. Huh. What if I, like, go through, like, -1. Here, start -1. What if I do that? Or no, plus 1. Try that. Whoops. Yeah, okay, so that works. Let's see if this works. No. Oh, no. No, it doesn't work. The first answer is 9. Oh my gosh. Which is not right. There might be a way. Okay, let's keep trying. I feel like we could keep trying. You could definitely keep trying. So I know we have to print out 9s and 8s because I know. Let's see. Let's go back to our examples. Okay, so if we wipe out the last n digit, find an integer minimum x whose r is maximum possible. Excuse me. How long am I doing this problem? Like, how long is the live stream? Was that your question? Yeah, I know Taurus is like number 1. He's been doing it since Codeforces. Taurus has been doing it since he was like, what, 10 or 11, I think. That's what I heard. So that's why he's like really good. He's been like doing these contests since he was like a kid. Let's see. Okay, I don't get your question. Like, what do you mean by like how long am I doing competitive programming? Like I just started. Like, or do you mean like by the live stream? Let's go back to this. Okay, so if you were to, let's see. Okay, let's go back here. So I know our brute force definitely works, but there might be a way to optimize it. We might not actually have to decrease this that much. So what if we just compare like the first and second one, right? Because 9999 and the 9998, see which one's larger. What if that's the answer? What if that is the actual answer, right? Hold up. Okay, well, let's try that. If that's the answer, that'll be wild. So instead of decreasing this, we just check 9999 and then 9998. See which one's larger, and then we set that. So, wait, no, but no, wait, that's not true though. 999, 998, 9999, 9998. What if you brute force? So instead of doing this, what if we brute force every combination of 999s and 8s? And then convert it to binary. Because if you were to brute force that many, that doesn't take that long. Right? This takes a while. Like if I start at 9999 and I go down to 0, that takes a while. But if I were to brute force a certain number of strings with 9s and 8s, with length n, that might actually not be that hard. So I might actually do that. Okay, so I'm going to create like a vector. This is annoying. Let's create like a vector Boolean. No, yeah. Let's create a vector here. Let's brute force all the possible values of 9s and 8s with size n. So let's do that. So we're gonna have a string, all possible values, and I'm gonna call it brute on all possible values with n. Okay. So let's do a void brute all possible values. This is the vector all pos. So this is gonna be what we're adding to it. We need to have the current string and then the length of n, right? So the length n, yeah, the size that we're brute forcing. So our current string we're gonna pass in is empty. So let's pass in empty like that. Yeah. So now we're gonna brute force all possible values. So to do that, all we have to do is just check. Oh, I need a current size also. Cur size. This is gonna be the number of digits we're currently at. Actually, technically we don't need it. If current size is greater than n, we return. So that means we reach the limit of number of digits we're adding. Otherwise, we're gonna recursively call brute and then pass in all positive and then n minus 1. Wait. Pass an n and then current plus concatenate it with 9. And then we brute force all pos with n. Current pass in 8. Right? And then after that, we just pass in 9, pass in 8. If the size is equal to n, So if current size is equal to n, we're going to push back to all pos. So here's else if cur size is equal to n, we're going to do all pos dot pushback current. Yeah. Okay, I think this works. I'm not sure though. Let's just like print out all pos after we brute. So let's for I equal. There's a lot of effort trying to brute force. See out all pos at I. Okay, so if I put 3, it should give me all possible values of 9s and 8s with size 3. So let's do this. 3. Okay, so he has 999, 998, 9989, 988, 899, 898, 889, 888, 9980. It repeated. Why did it repeat itself? I don't want it to repeat itself. 9998. It repeated itself twice. Why did it repeat itself? Should I return here? Not even sure. Well, it still repeated itself. Yeah, I don't know. I don't know why it repeated itself. But let's... So now, once we brute force this all, we don't need this number. Actually, we still need it. No, we don't need this. We don't need this. This is going to be... So yeah, we don't need this xtoll thing. This one we're going to loop from I equals 0. I is less than to all pos dot size and I plus plus. And now we're going to convert all pos at I to its string, but it is a string, so that's what it does. Then we do all this voodoo nonsense. Why is x strange? What's the problem with x? X is undefined. Oh. Oh, okay. X was our yeah, X was our initial value. So let's actually convert this into its... So we still have to use this weird s-toll. So let's do x is equal to s-toll this. And this is going to be current string. That's C string and pointer 10, yeah. And then that'll fix that. So yeah, I think this is a little more efficient than the other one. Because there's only a certain number of sizes you could do this. Because before we're starting 9999 and going down, right? Okay, so that there's that. Now we only brute force a certain number of positions possible, and then that's that. But I'm not sure if, based on the constraints, if it's still inefficient. That's what I'm not sure. Memory exceeded. Damn. Haven't had this before. We can't use that much memory? My gosh. It's not like I brute force. Well, I mean, I did brute force, but it's not as like... okay. I think it's time to look at the editorial. What do you guys think? How long have you been doing computer programming? I just started a few months ago. So like a month ago, or two months ago. So yeah, I'm not that good. Okay. Yeah, let's look at the editorial. All right. Consider x consists of digits 8 to 9. Yes, we know that. This is so because if x considers 0 to 7, their binary digits are shorter than 8 to 9 than the number of number k written on the board. Wait, what? Shorter than the number, which is shorter than the number of k written on the board. Okay, yeah. Therefore, the number r, removing the last digit, will be shorter than if you use the digits 8 and 9, which means it will not be the maximum possible. Yes, yes, so that is true. That's the issue I was having. 8 and 9, that's what I knew. The more x, the more k and r, therefore to maximize k and x would be 99999. Yes, that's what I was thinking. However, due to the fact that r is k without the last n digits, at the end x, it is possible to replace a certain 9s and with 8s so that r would be the maximum possible. The number of digits 8 in x of length n is equal to n over 4 ceiling. Where did he get that from? 8 is 1000, 9 is 1001. We can see that the binary notations of the digits 8 and 9 are 4 long and differ in the last digit. Yeah, we know that. Suppose the suffix of the number x consists of p digits 8. Right, yeah. Then the maximum r is achieved if at least 4 times p minus 3 digits are removed from the end of k by the concatenation of the problem. Exactly, n digits are removed, which means 4p minus 3 is less than or equal to n, and then p is equal to n plus 3 over 4, which is equal to n over 4 ceiling. What? So p digits 8 is equal to n over 4 ceiling. N over 4 ceiling. Okay. So we're going to loop through 3/4 of the string and put 9s, and the last fourth put 8s. That's what I'm getting from this. Okay, I guess that does work, but I don't understand the proof. I guess that is right. Let's get rid of the brute force. Okay, yeah, we don't need this. So he wants us to loop through 3/4 of the string. 3/4 of the string, so 3 over 4 n. And then just print out 9s. Then the rest do n over 4 ceiling. Print out 8s. I don't understand the proof at all, though. Why 3/4? That doesn't really make much sense. Because if you're putting seal, I don't get it. I don't get it. Let's just code this up. What is going on? What is going on? 9. What is going on? Oh my gosh. Ceiling of this. Oh boy. 3/4 of n. Oh my gosh. Okay. What am I doing wrong? 0.75 times n. Okay, convert this into integer. No. This is annoying. 0.25 times n. 89998. Okay. Okay, that's right. Let's just submit it. I don't understand the proof though. Compilation error. What? Oh my god. Oh my god. Oh my god. Come on. Why is the queue so long? My internet. Okay, I got AC'd. Okay, so that's right. Okay, that was a long ass problem, and the answer was just 3/4 of the string. But I don't understand the proof though. Like I understand it's 9s and 8s, but this I don't understand. Yeah, I know it's with 9s and 8s, but statement 3. We can see that the binary notations of digits 8 and 9 are 4 long and differ in the last digit. Suppose the suffix number x consists of p digits 8, right? Then the maximum is achieved if 4 times p minus 3 digits are removed from the end of k. Why is that? At least 4 times p. Why? Where did this come from? Because if let's say I remove these digits, right? So 8 is 1000, 1009 is 1001. If I remove the last 3, I don't understand. I just don't understand. Suppose the suffix has a digit 8, then the maximum r is achieved at least 4 times p minus 3 digits are removed. Do you guys understand what they mean by this? For me, it's 12 a.m. where I'm living at. Except for 9 and 8, all have 3 or less numbers. 3 or less numbers. 4p minus 3. If you remove the last 3, I suppose you're right. P or less numbers. But that okay, so like, why 4p minus 3 though? Look, where did 4 come from? Okay, I get it. That's like 4 long and they differ in the last digit. So, are they saying remove the last 3 digits for every 4th end of k? But then where did this come from though? Why is it always less than or equal to n? Right? That doesn't... Alright, you guys in the chat, help me understand what I'm doing. Oh, this is so ridiculous. I don't know. Alright, I'm going to end the live stream now. We solved the B problem after looking at the editorial and coding it up. But I just don't understand. I feel like this is not... This is kind of like a got you, you know? Like if you figured out the observation. It's not really like algorithms, you know what I mean? It's more like, were you smart enough to figure this out? Like, cause the jump from here to here is pretty difficult to comprehend. Like 4p minus 3. Like how are you so sure that that's right? Right? If you're going down through these. You know what I mean? Like you're just gonna put 9s on the first 3/4 of n, and then put 8s on the rest. Like that's kind of a far-fetched jump, you know. Let's see what they meant here. Let's look at the other. Let's see. Ah, damn. Question B. Problem B. No, I don't think the problem B was pretty obvious. So if you think problem B is pretty, I don't think problem B was obvious. Like if you like I don't know. Let's see this guy's ranking. He might be really good. His rank is way higher than me, but let's see. It's problem B. Okay, so he solved 2. Okay, so he's like, oh, the problem B is so easy. Oh. I don't know. I didn't think it was basic observation. Why is it on greedy? That's what I don't understand. Why is it so? They made me think that it's like math, but this is not really. Why is it greedy? What are you greedily selecting? 8 and 9? Like that's not. I don't know. Let's see. I don't know. I didn't get AC. I had a C because I was using Python. Real and C++ I got AC. You don't use Python recursion. Yeah, that is true. Oh no. Feels bad. All right, tomorrow we'll try to upsolve C. Okay, and then yeah, every day we'll try to upsolve the same problem until we get to 661, and then maybe I'll try to like another virtual contest myself, because I have not been practicing at all for the past weeks. You can check out like my. If you guys really care about my handle, like I show you my handle pretty much. If you want to search me up, just go ahead. I don't really care that much. But yeah, I haven't been participating at all. Like, see all these contests, I have not been participating. So like my ranking definitely dropped. Did I upsolve 656? Oh crap, guys! I forgot to tell you guys. I upsolved the last problem D on 656 yesterday. I didn't actually live stream that. But yeah, maybe we should upsolve those. Also, moving edges, column swapping. I feel like if you the first 2 problems are not really algorithm problems. They're more like observation or math, and then the rest of them are. So like I feel like if you want to improve your algorithm skills, you really should upsolve the harder problems. You know what I mean? But yeah. Oh, I haven't upsolved this yet. Oh, I haven't upsolved these 2. Huh. Okay. All right, guys. From now on, I'm gonna try to upsolve A, B, C, D for every contest I participate. Excuse me. Every contest I participate in. So yeah. See, look at these. I only solved first 2 problems. I have not actually been upsolving. So that's one of my reasons why I think I haven't been improving at all. Also, I just haven't participated in any contest. Part of the reason is like if you show up. Oh, this one I upsolved all of them. Yeah. I feel like if you upsolve this one used segment trees, I remember. That was wild. Wild. Okay, yeah. Anyway, all right, I'm going to end the live stream now because I'm really tired. Right now it's 12 a.m. here, 12:30, 6 a.m. What time is it in India right now? Let's see. What time is it now in India? Oh, it's 10 a.m. Wow. So you guys are early risers. Yeah. Notice pattern by printing string. Notice pattern by printing string. That's true. I mean, if you print the string, you might notice a pattern. I guess. I don't know. Tough questions. All right. Rate, comment, subscribe. Check you guys later. Peace. Bye, guys.